Good afternoon, everybody, and welcome to today's webinar. And we're going to focus today on an extension within for PTC Creo called Generative Design. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And leading the presentation and live demo will be Zach Carson, who is a solutions consultant and applications engineer with PTC's Virtual Center of Excellence. So everyone's going to be on mute during the webinar. And if you have any questions, feel free to type those into the question and answer box. We will try to answer those as we go along, but we will definitely answer them at the end of the webinar. So I'm real excited about this because this is a tool that can have a dramatic impact on the products that you make. So basically, when you're thinking about getting compounding cost savings from using less materials, from having less scrap and rework, this is a tremendous capability. So Zach, without further ado, why don't you take it away?
All right, thanks, Rob. So as Rob said, today we're going to be talking generative design. The idea with generative design, really what it's there for, it's an extension in Creo that helps you autonomously create designs from a set of design requirements that you lay out. And then it's going to use the power of the cloud to analyze multiple design studies simultaneously. So when we talk to people, the companies that need generative design are typically dealing with the same challenges. The first of which is just a struggle to drive innovation. That's never going anywhere. Every company deals with this challenge, some more than others. But without tools that actually help you innovate, you're putting yourself behind the 8-ball, really making it difficult for your products to be competitive, which is obviously what you need to maintain your spot in the market or your advantage in the market. There's also the challenge of closing the skill gap. We're in a time when a huge amount of the workforce is retiring. Lots of them are taking their knowledge with them and leaving younger employees a little bit stranded. And I've seen this firsthand in my own experience. Companies really struggle to find ways to close the skill gap and give the new young designers the ability to create innovative and quality designs, even without the deep industry knowledge and experience. And then, of course, you always have to push to be more efficient, to be more productive. That's another challenge that's always going to be there. The last point here, closing the skill gap, makes this even more difficult. You have new people coming in, you still are trying to be more productive while also just learning how to use these tools. So you have to give the people in your company the tools that actually help you be more productive and achieve more in less time. PTC's solution to these challenges, or Creo's solution to these challenges, is the generative design extension. And there's really two main components to this. The first one is generative topology optimization, or GTO for short. This is going to give you the ability to autonomously create designs from a set of design or system design requirements. So we're talking loads and constraints, materials, even manufacturing processes. Then there's the generative design extension, which is the second piece of this. And this takes GTO, and then it's going to utilize the cloud to promote collaboration and then expand the processes and the capabilities of GTO by doing basically comparing multiple design studies simultaneously. So GTO is really at the core. You can either have GTO by itself, or if you have generative design extension, it'll take GTO and then just build off of its capabilities. And I'll discuss here the capabilities between the two of them. So starting with GTO, this is the first main section of generative where we're laying out really the different goals and requirements that we have for our use case. So think of this as you're coming into Creo and you're putting in your materials, your physics, your manufacturing constraints, etc. Based on those specifications, Creo takes all of those and it generates designs that you and me probably would never think of on our own. And we can either use those designs as the base of a design that we're just going to trace and then build off of, or you can go in and refine it and use it as a concept design or concept generation for other designs moving forward. while the system is building these designs, you can visualize in real time what GTO is creating. And that's even true if we make modifications to any of the input geometry or the design criteria that's actually been laid out ahead of time that's defining our geometry. Now, once that design is generated, you're able to go in and interrogate it. You can do some simulation on it. You can analyze stress values. You can look at deformation and see, how it's going to bend and flex, and actually get a full understanding of the quality of the model that Creo generated for you. And the reason that we're able to do all this is because of our integration with Frustum technology. It's built right into Creo. It's not a separate window or software that we have to switch over to. It's just you build your design within Creo Parametric, or you lay out your design constraints and everything in Creo Parametric, and then you just click Generative Design tool at the top of the toolbar, and it's going to take all that into account and build this. And you can take that design and then tweak it, modify it, use all the rest of Creo's standard modeling capabilities right on top of what it created for you. Once you get your results, you're able to output the results to B-rep geometry and then continue building off of it, making changes to it, like I just said, and refining it. Or the other option is you can just leave it as a tessellated model. And if you're doing that, you're probably using it more for concept design, and then you're just going to create your own designs based off the generated model. That's all GTO. Now that you have a better idea what that is, we can talk about specifically GDX, which is the next level from GTO. And this is all about, GDX is all about taking what we got in GTO and then utilizing the cloud to enhance our abilities and take generative design to the next level. Getting started with this is pretty simple and straightforward. There's nothing extra you have to install. You'll have direct connection to Creo, or you'll have a direct connection from Creo to the cloud. And it's basically as simple as you just do one click and you take everything that you built in your GTO study over to the cloud, and then it'll open GDX within the embedded browser inside of Creo, and you'll be able to run your comparisons and look at your results there. From here, we're using high performance cloud computing to then set up and generate the design. So in that setup, you can go through and select different combinations of design criteria that we want. And GDX is going to run through your selections and generate your designs. And we'll take a look at this actually in the demonstration. The nice part about this is your selections can vary. You can store all kinds of different design criteria in the GDX study. And then once you open GDX, if you don't want to include, let's say, the steel low carbon or the ABS, you just unselect those boxes, and it'll run the generative design study on the remaining selections that you have. The results you get from the study can be customized to filter based on really any criteria you want. For example, you could look at all the different results you got based on the material you chose for each iteration, and then compare them and find the generated model within your material selections that has the highest safety factor or the lowest mass, for example. And again, lots of different ways for you to visualize the data here and filter through the results through things like graphs, charts, sortable columns, list and grid displays, and then all of it, you can actually cross-highlight between the results. So you can make selections in a graph and then highlight a certain area on a chart, and it's going to cross-reference everything and really give you some advanced filtering capabilities to narrow it down to the optimal design. After that, you could take the results or maybe even select a few iterations of them. And maybe you start with 12 designs. You've selected a range of a few variables that you want to compare that are pretty important. And maybe you've narrowed your search down from 12 original designs down to the 3 that make the most sense. And then you can do a stack up and compare those side by side and determine which one is actually performing the best. And once you figure that out, we'll then take the design, share it with other people, collaborate with other people in your company, with your coworkers, figure out a best way to go forward. This is another huge hurdle that a lot of companies have, and this tool makes collaborating a lot easier. You'll even have in here a full history of stored in Creo of the design of the generated design. So you can go back and you can look at previous iterations at any time, look at your progress, see what you've done to change and refine the model to actually get where you're at now. So before we get into the demonstration, let me see here if we have any questions, and it does not look like we do. So we'll go ahead and jump into Creo then.
Lovely.
All righty. So for this demonstration of generative design, we're going to be working with with an assembly that we have of a Royal Enfield motorcycle. And specifically within this, there's a particular part of it that I'm going to focus on, which is the clamp that is part of the steering column. So before we get into it, just take a look at this so you can see kind of what we're working with here. All right, it's going to be this piece down here. So what I want to do is if I isolate this, you can get a better idea, top and bottom, kind of where we're starting. And I want to take this piece, and maybe it works perfectly well how we have it now. It might not necessarily need to be changed, but maybe you want to try and find some ways to change it, save some money on material or something like that. So we're going to see what GDX can come up with. Now, instead of the one that we have on the model currently, what I'm going to do is I'm going to take a more simplified version of that part. And this is what we'll use to run the generative study on. So if you take a look over at the model tree here, what you'll see is I use the multi-body command to create two bodies from this piece. So we have our envelope, and that's where everywhere the part that GDX comes up with is going to be contained within. And then we have the preserved geometry, and that's the area of the model that I want to make sure that is not being changed. I want to make sure that I'm keeping that in the end. So to get started with this, we're just going to go up to our Applications tab and open up Generative Design. And as we're going through this, if you're looking at the toolbar at the top, we're basically going to be working from left to right. If you don't already know, Creo kind of does that a lot with the tools that you use. It goes a long way for people that either lack some experience in Creo or also just lack experience in doing this type of work. So first thing we need to do is just start here with our starting geometry. We select that, and then we can go into laying out the different constraints that we have. Okay, put a fixed constraint in the middle. And these are just all of our design criteria. Okay, put some loads on these outside two holes. That looks pretty good. And then the last thing for this one is I want to actually go into the different, or show you the different options here in the generative tree. So as you can see, there's lots of different options for different materials. If we're doing 3D printing versus milled versus cast, so you can store all of these different options here. For this one, we're going to go with this milled O2. And when I select on this, after we've laid out all the physics and the design spaces, then we can open up the design criteria. And this is where you're actually going to go in. You're going to say, all right, I want to limit my volume to 70%. I have certain design constraints for extrude direction, extrude angle, the materials I want to use, but I can come into the materials library of Creo and add more of these or remove some, just add a low alloy to the model. That looks pretty good. And then the last part of setting this up is just to go into the study settings. So basically for this, I'm just saying, okay, do I want to move the slider to change my fidelity if I want more accurate results versus faster results? And do I want the minimum element size for the mesh, or even the amount of max iterations that I want the study to run? At this point, we can go ahead and optimize this one design study for this one material right here in Creo, and that would all be done with GTO. Or what we can do, and what you're seeing now is where generative design comes into play, is we can send this to the cloud, and that allows us to use many different design criteria with multiple materials for each one. So we're doing this just right within the embedded browser inside of Creo Parametric. We're not leaving the tool at all. You just log in to access our cloud environment, upload your study, and now the cloud platform will calculate all of the possible solutions based on the setup, the parameters, the processes, and so on. So in this case, here's my embedded browser. And let me scroll down a little bit here, and what you'll notice is that the setup here on the left-hand side of this embedded browser is just the same as what we have in the generative tree that you see on the very left-hand side of your screen. For this example, we added a study that utilizes a new material. It's steel low alloy. And you can see that now within the embedded browser under the milled O2 selection, that we now have added that new material. We want to include that in our study, but it's unchecked. Okay, that's because it's new. We haven't included it in the generative calculations yet. So we'll just go ahead and select that. And then what happens is once we've made all of our selections, it's as simple as just coming up to the top. And you can see I have one design to generate, which is the one that I just mentioned. And we can click generate. And it's going to take into account all of the selections that we have on that screen, all the criteria, and generate models based on all of that criteria. So in this case, there's, 12 of these? Yep. So 11 have already been done. We added in that 12th. So that's going to take a minute to calculate, but you'll be able to see the percentage live. The results of all the previous ones are stored in here, so you're not going to lose them. Anybody who comes in can see the results of all of the other generative design studies that have been run in the past, and then also stack that up against the one that we just created. All right. Once you have the designs generated, then what you can do is start to filter out on the criteria that is stored in here. So I can go into my different design criteria. I can go into my different materials. I can go into different charts and graphs, as you can see, like I'm doing. Maybe I want to look at everything, or I want to just look at something at the options I can 3D print, for example. But the idea is store it in here, let Creo do all the heavy lifting with making these designs, and then I can just come in here, click around, and filter on the criteria that's the most important to me. So you can see it's all interactive. I can drag these different variables in the chart. I can select, I can highlight different ranges, cross references with chart at the bottom. Maybe I want to look at mass for just the top 3 options here. You can see it's filtering down on these selections that I make based on what I'm highlighting in that graph. All right. Now with the selections we made, you remember we had 12 original options, but now I'm down to 6. So maybe I want to continue to refine this a little bit. I want to continue to filter, and now I want to hone down to, let's just say, 3 of these models. So I can use this graph in the top right, maybe look at mass, and I can say, all right, this one in the upper right, which one is this? It highlights on the design options in the bottom. Maybe I want to look at these 3 because these are adhering to the different selections that I've made. And what you'll see is then within this tool, we actually have an option that allows you to compare what you have selected side by side by side. So I can take a look at this. It's going to give me a contour plot that's applied to the model and is displaying von Mises stress, or it's displaying deformation. And I can even animate this and see when it bends and flexes, is it moving in the way that I expected it to. And if you look at those models, you can see some of the differences between them. Right? You can see the members across the middle around that center stem. Once you have gone through and you've done your comparison, looked at these, there's a clear picture of the models that we have, and you've taken into account all of your different criteria that you have, and physics and manufacturing methods that you want to use. Pick the one you want. And at this point, we want to take this model from the generative study and we want to send it back into Creo, from the embedded browser back into Creo. And you can do it right from this window. So I'm going to take design 12 and I'm going to save it here as a new file. It just takes a second. And with this part now back in the modeling space, what we can do is go back to our generative design tab, and we can actually use it to officially generate this design either as a tessellated model or a reconstructed or reconstruct it to be rep. And once you've done that, then you can start to utilize all of the other capabilities that Creo has. So if I want to tweak the geometry, I can do that. If I want to do maybe some analysis or maybe even use Creo Simulation Live on this piece, I can do that and kind of use it to guide my changes that I'm going to make to it. Okay, so I'm going to take this model. Maybe I have a simple CSL study set up already, and I want to just take a look at the von Mises stress and deformation and tell me the points where I have some max stress or the max stress points where there's areas of concern. I want to monitor those. Maybe I want to put a simulation probe on there or something, with the idea being just it generated this model. Now let me use the model, see, generally speaking, where we stand in terms of the quality. And then I want to use that to make some changes and maybe then bounce back into CSL and see, as I make the changes, how the model's being affected by those changes. Once you've done that, another piece of Creo, and this isn't exclusive to the generative design study, but a way that, or a tool that a lot of people use hand in hand with it, is to create an interchange assembly. And basically what we're going to do now is I can say, have different models that GDX has designed, maybe I've designed by hand, that have different properties or that I want to be able to replace within my assembly. And I create an interchange assembly on those with those models that allows me just to go to my bill of material and say, okay, which one of these do I want? Maybe the customer prefers one that's 3D printed. I can make that selection. Maybe someone prefers one that's milled. I can make that selection. And then I can store that in my assembly and actually use my interchange group to just quickly come in here and pick the right part that I want, right? You can see if you want additive, casted, milled. Maybe I want milled in this case. I press OK, and then you can see that here update in the overall assembly. There we go. And this one, maybe this satisfies my original design. It cut down on some material. I can 3D print it, so it makes a lot of sense. Right? So the idea here is we are using generative design in our designs to come up with shapes and models that we probably would never think of on our own, but they're going to be optimized for your processes and preferences. So with that being said, I have a few more points here that I just want to mention that kind of summarizes what this can do for you. So number one, it's going to reduce time to market. You're not only able to go through and try out different designs faster, but you're able to do optimization and analysis right alongside it. You're actually combining two parts of the design process that are typically very disconnected and time consuming. And another really big thing with this tool is just you're able to create designs that are innovative, they're differentiated from other designs that other companies are coming up with, and they're high quality, most importantly. These are designs that are unique. They're not things that every designer is going to be coming up with consistently. They're unique. They follow your processes and they have specific qualities and properties that you identify. And then throughout this process, you're able to reduce cost through the use of minimizing materials used to actually produce them, minimize the amount of different parts that you need. You know, you might be able to take something that's typically made up of 10 different parts and condense that down to 3 using generative design. And then in the creative designs that comes up with. So that's what I had planned to take you through today for our demonstration of Creo generative design extensions. Thanks for coming, everyone.
Cool. Nice job, Zach.
Thank you.
So to kind of attach on to what Zach just reviewed, if you think about it, if you're able to utilize, fewer parts in your assemblies or use less materials, if you had a $30 savings, just a $30 savings in materials for one specific product, and you sell 10,000 of those products, that's a $300,000 savings just for that one product alone. And if you have a solution like, for example, with Volvo Trucks, who's using these, or Cummins, who's also using generative design and topology optimization, it's not just the savings of like over $1 million or millions of dollars in savings because they're using less materials for their engines or for their truck parts. But also now their trucks are helping trucks, well, Cummins engines are helping trucks become lighter. And they're also that lighter truck is operating more efficiently. It's utilizing less gasoline, less fuel. So there's definitely a lot of tangible benefits to this solution. Also, you're going to get improved quality in your products overall. You're going to have less rework, and of course, it's going to reduce or minimize scrap tremendously. And also, because of the being able to utilize the innovation of what this does, you'll come up with designs. I don't care how long you've been doing engineering and design, this will come up with ideas you never thought of, because it just thinks completely out of the box.
Yep.
And it's great for new product introduction. If you want to introduce new products, if you want to try and test new ideas, this is also a great tool for that. And then you're going to meet your deadlines. I mean, I think a lot of times, because of an assembly or a part going downstream that needs to be reworked, that's always going to delay the process. This tool is going to help you get it right the first time. There's minimal rework, and this is also going to empower your design and engineering department a lot more and make their job more fun. So I just wanted to piggyback onto those last points that you had made. So I want to thank everybody for being on. If you have any questions or you want to see a more detailed demonstration, just reply to the email invitation that was sent. That'll come to me, and we can set up a more custom demo for you. We can set up a custom demo for you for pretty much for anything, whether it's a Creo solution, wind chill, augmented reality, code beamer. We could pretty much set that up for you. So Zach, I want to thank you for being on today and leading us, and the recording will be posted and sent out by tomorrow. So thanks everyone for being on. Have a great day. And since it's Thursday, enjoy your weekend and your Friday.
Thanks for coming, everyone.